Good afternoon. Thank you all so much for joining us. I am, as you may have guessed from the schedule, Renee Huinker. I'm here to talk to you today at PG Conference, New York City. The title of this talk is Exacting Standards. I know we had a couple of talks about the SQL standard today. This is not one of those. What we are talking about today is accuracy and precision in your database. Mostly we'll be talking about accuracy, but we'll touch on precision just a tiny bit. So the very first thing we need to do is a speed run about data and data quality. So we'll start with data, and we'll all agree that data is one or more of these things: pieces of information with a format, facts used for making decisions, information stored in and or used by a computer, a representation of some aspect of the world. Now that we know what data is, we need to know what good data is. And in my mind, that is simply data that is useful and fit for its intended purposes. And that may be things like operations, decision-making, planning. And of course, we want good data so that we can achieve things. And some of these things include planning, operations, possibly looking smart, maybe saving money for ourselves or our companies, making decisions, and of course, our obligatory database joke, we want to complete transactions. So now that we know what good data is and why we want it, we need to think about how we can assess it. And this is where the topic of this talk comes into play, but we're going to do, like I said, a speed run of some other aspects of data quality as well. A huge list of things that we think about generally when assessing data quality: completeness, uniqueness, timeliness, validity, accuracy and precision, consistency, and have recently added compliance. So for completeness, we want to make sure that we have all of the information we expect to have, and we have enough data to do what we were expecting and planning and hoping to do. Uniqueness, we want to make sure that we don't have any duplicates in the database. We want to make sure that each item is represented only once, even if that row is not necessarily an exact duplicate of another row. We, of course, want to make sure that we have the most recent data possible, and we want to be able to know that our data is accessible quickly. We want to know that the data is valid, the syntax and type and format are correct, the data could be accurate, the data is in the expected range, and there are hopefully no unexpected null values. Now we get to accuracy. Have we stored the true value? We are not going to talk about whether or not truth is possible. That's an entire PhD topic. Feel free to enroll in a program for that. We also want to know that the units of measure that we've chosen are appropriate. I think of this as, did we hit the target? Not did we hit exactly the right spot on the target, but are we like in the area of the target? And then precision is the exactness of measurement or description. I think of this as the granularity or like the size. Are we at the right detail level? Are we describing a tiny toy truck, or are we describing a giant tractor trailer hauling 3 loads? Very different situations, right? Next to last, we have consistency, looking for, are there conflicts between sources of data? This might be a problem, right? And then a thing that we think about broadly is the database doing something to our data that makes a change to it in ways that we don't expect? That's a problem for consistency. As for compliance, we want to make sure that our policies and practices for data collection, storage, and use are lining up with the letter and spirit of applicable laws. Going back to accuracy, I think of accuracy as having some components, and this is why I ran you through all that list of qualities of data, because some of these are related. Accurate data is generally the most recent data. Not always, but generally. It's generally the most complete data. Accurate data is generally consistent. And accurate data, I would say, is always valid, in a valid format or syntax, right? So now we have to talk very quickly about what we think of as the data pipeline or the data funnel. This image makes it look like magic. You put a pile of data into the top of a funnel or a hopper and something magical happens inside it and out the bottom comes profit. We know it's not really like that. The data journey is more like a road trip with winding turns. And we need to think about the kinds of data that we have on this road trip with us. Some of the types of data that we have are quantitative, which you may know are easily represented as a number. And other types of data that we'll come across are qualitative, which are things like moods and opinions and colors and reasons that aren't as easily turned into a number. So of course, we'll start with numbers. Things we want to think about with numbers primarily are storage and math. So starting with storage. From the Postgres documentation, there are several different ways to store numbers. I've marked in greens the one that I think you should use, and some that I think are generally a good idea to steer away from. This is, as I said, from the Postgres documentation. So integers, wonderful. You can do a lot with integers. Decimals, great. Numerics, awesome. Real numbers and double precision numbers, these are also sometimes called floating point. They are useful. A lot of people really love them, need them for things, but for most people, please do not. Here's a smaller version, larger resolution of the list of what I would call your approved numeric types for most people. And the reason for this, again from the Postgres documentation, is that exact storage and calculations should use numeric type. And this is specifically in regard to floating point numbers. And the reason for this is that the storage of these numbers requires a special kind of rounding inside the computer or inside your storage. And math on inaccurately rounded numbers is going to end up with an inaccurate result. So here we have some examples of lots of numbers. The first two numbers on the screen here are showing us a lot of precision. One is precision after the decimal point. We have an idea that something very small is being represented with those 6 places to the right of the decimal point. And then in the second number, we have a whole lot of whole numbers, billions in fact. And I want to point out that it's very possible that the number at the bottom of the screen, 8.2 billion, is possibly the most accurate number of this bunch. Sometimes it's very tempting to look at a very precise number and think, they must really know what they're talking about. They got all the way down to the 10,000th of a degree. They must have really been measuring that perfectly, but maybe something was miscalibrated. So when I think about precision, I think about the relative size of the smallest data point that can be described in a situation. So we're talking about things like temperatures, but we can also think about GIS, geographical information. If we want to look at a manhole cover in the street, we're going to need a different level of precision than if we just want a mountain range, or is the river in this place? We also think about precision with things like a fraction of a coin. And this is part of where floating point math is dangerous. A lot of companies get the temptation to use money, again, either with floating point types or with the money type. It is conveniently called the money type, but please don't use it for money. Some corporations do actually need to do math on fractions of a coin, whether that is for currency purposes, such as currency conversion, or just currencies that aren't in the US dollar sense. However, would you talk about fractions of a seed for a little tiny plant? Maybe, but not necessarily. So your precision is going to vary depending on your context. So now that we've talked a little bit about storing numbers, we're going to talk about, well, a little bit more about math. It's worth repeating from the Postgres documentation. If you need exact storage and calculations, use the numeric type instead of the real numbers. It's also important to think about what you're doing to your numbers. It's one thing to have stored your perfect types. It's another thing to be actually doing math on your numbers. And I urge everyone to double check the processes that your numbers go through, as well as the arithmetic and other mathematical procedures that you do with your data. An example of this that I like to give is one of my clients had, we'll call it a gift card. They had a gift card program where they sold or gave to customers denominations to spend. And what was happening inside the code was that every time a customer spent the gift card, the amount of the spend was added back to the value of the gift card. So if I had purchased a $100 gift card and used it 3 times, each time for $100, the company would tell me that I had $400 available to spend on my gift card. This was great as a customer. When I discovered this, it was about an $800,000 problem. And this was just because a plus sign was in place where a minus sign should have been. So this kind of attention to detail can really potentially be very embarrassing for a company. Like I said earlier, we do want to look smart, and we do want to make money and save money, and we also want our accountants to not think that we have greater obligations on our books than we necessarily have. Pardon. So we've talked a little bit about numbers, and now I want to talk about text. If you were in Ilya's conversation yesterday, he had some really great suggestions for Postgres worst practices, and one of his worst practices was just save everything, absolutely everything, as the text type. Text type is very helpful for lots of things. It's an extremely great data type, and I do love it, but it's not for everything. What is interesting, though, is how text gets into your systems. I think of this as being speed versus quality versus staffing cost, because people are expensive and we're kind of slow. We're also not really that great at some kinds of input. There's a problem with deletion. A human being is typing, and you'll see on the top what would be an American phone number, except that there's a digit missing. And we have no idea where that digit might be missing if our system has put those dashes in for us. If the human being doing the typing also put the dashes in themselves, then we're pretty sure that it's the last digit that's missing, or possibly something in that last quartet of digits. If you know the song, you would recognize possibly that it was the 9 missing offhand. In our second example here, the deleted item is a decimal point, which gives us a difference of about 10 times the amount of money. So this can be a very costly and significant error, a deletion. Then we have transcription, which is when a character that should not be present is added. So this is something like adding an extra digit at the end of our phone number, which many of our modern day American phone number recognition systems will say, oh, hey, that's not an American phone number. And we could also add that decimal point and make an item significantly less costly than it was in reality. Next, we have something called dautography, which is mistakenly duplicating a character. So the character does belong there, but it belongs there only one time. So perhaps something that should have cost $190 only cost $1,190. Small error, right? And then we have haplography, which is a character that should appear twice, is only entered once. So we expect an item to be $190, and I've highlighted the wrong digit here. We expect it to be $1,190, but we've recorded that it's only $190. Another thing to think about with text is if we wanted to describe a location, we can do that in a lot of ways if we're using text. we don't know if all of these are accurate. We also may think that some of these have different levels of precision. For instance, what if there are 6 donut shops on Pine Street? What if there's a donut shop on Pine Street and Pine Avenue? What if there's, Pine Avenue Street Drive Way? Could be anything. So describing locations is really hard. Postgres has solutions for geographical information stuff, and that's PostGIS, and I don't have anything real about PostGIS in this talk, just to say it's great, you should use it. Be aware that there are ways to describe places and lots of things that provide you more accuracy and precision than text allows. So these examples provide some clarity on the kinds of confusion that you can create when choosing a data type that's not well suited to what you're trying to relay. Another thing we want to keep in mind is duplicate data. Primary keys, of course, are your friend, but they won't save you. I used to work in medical settings, and a thing that's very common is for a patient to call and say, I'm a new patient, I'd like to make an appointment. And the person on the phone is dutifully typing the information in during the phone call, rather than making a paper form. So you've got Mrs. Jones on the phone, and you've got all of her information in the computer, and you save it, and Mrs. Jones's husband pipes up in the background and says, you've already made that phone call. You're already in that doctor's system. So now we have Mrs. Jones twice in the doctor's office computer. And because this is a medical legal setting, we cannot remove the second Mrs. Jones without a lot of legal oversight. So now what happens is Mrs. Jones comes in for her new appointment, and we enter some of her information as Mrs. Jones, the first phone call, and we enter other of her information in the entry for Mrs. Jones, the second phone call. So now we have to figure out, how do we merge these pieces of information together? We also have the problem with people with pieces of data that look to the human eye as though they might be duplicates. I had a mother-daughter pair with the same birthday, but they were exactly 30 years apart. So it was like 1956 and 1986. Their social security numbers were exactly 1 digit off. And they still lived together because the daughter had a developmental disability. So they had the same address and the same phone number. And staff in this office were constantly trying to insist that we merge these records, or putting the mother's notes in the daughter's notes, or putting the mother's financial information in the daughter's financial information. So a false duplicate is as much a danger as a true duplicate. And as much as I've been giving people a hard time, computers aren't that great either. So this is an example for me, and I was a human involved in this, right? And part of this is also the person who designed this intake, not an intake form, but a web form for the Flying Blue loyalty program for an airline. Oh, you know my birthday now. Sorry. Things moved. So what had happened was I signed up for this, and the computer told me that my birthday was October 10th, but I had inputted September 10th. And I found this very frustrating. At first, when this happened, I thought it was my fault. So I went back and created a fake birthday for a fake. I dirtied up their data a little more, added a fake person. And what I found was that someone had, in this web form, put December at the top. So December was counting as 1, making my September into 10, which was then October. And I confirmed this by putting in August 31st, and it told me, we can't validate your data. That's not really a birthday.
So that was how I confirmed that August 31st is a day, September 31st is not a day. It thinks I'm telling it September 31st. This is a funny story. This is computer programmers putting in an autofill for null data. So you have a list of recipients at companies, and sometimes you don't know the name of the person who holds a job title. So you want to make a placeholder. And someone at a bank decided to, for a program that was sending extremely high net worth companies a letter to offer them a deal, this engineer made the placeholder rich bastard. And the letters went out after that engineer had departed from the company, and no one else on the engineering team knew that that had been the placeholder. And nobody had time, as they were stuffing these hundreds of envelopes, to catch that there were, I don't know, maybe 5 or a dozen or 20 of these insulting terms. So maybe take a look through your data and in your PSQL and just have an eyeball for maybe you've got Shruggy Guy if you've changed your null to something recognizable. Time is near and dear to my heart. There are a couple of things that I want to talk about as far as time goes when we talk about accuracy. One of them is what I think of it as hindsight, but it's really more like adjustments. Particularly in finance, you may know that like when month end closes on the first of the month, accounting doesn't necessarily have all of the information. So on the second or third or fourth of the month, accounting has a better picture as time has passed of what has shaken out, what transactions really did complete on the 29th, the 30th, if there was a 31st of the month. So things can get more accurate with time. I know I said earlier that timeliness, the most recent data, is most likely to be complete and accurate, and this is an example of that. Another thing about time is that years are not treated the same in databases. So, especially time very long ago, this may not feel like it matters to us, but in some cases it might. So you should be aware if you're going to run into this type of a problem. And time zones matter a whole lot. Another one of Ilya's suggestions was to just use timestamp without time zone for absolutely anything. Don't worry about time zones. And this is a particular set of challenges because, for instance, this computer is set to the time zone US, New York. And sometimes when I leave the country, I change this time zone setting on my machine to where I'm going. And sometimes I don't. So if your application is set up to record the time zone of my machine, a thing may be happening in your database at a time that is not, in fact, true to where my computer actually is. So if everything is in UTC, it can be easy to calculate the offsets of that, but you may be creating other problems for yourself. So be aware of what you need your time relationships to be, because especially in legal context, did something happen on the 1st of the month or the 31st of the month, those things can be happening at the same, those dates may exist at the same time depending on where you are, right? Another thing to think about, totally unrelated to time, is Boolean. And I'm about to show you 3 columns. And I have seen each of these 3 columns used to store Boolean data. Only one of them is appropriate. So you load some data in. I loaded in a little more data than this to get some false examples for you. But not all of these things are obviously recognizable when you do a text search. So I want everything that I had put in initially to the database. and then I want everything where it's true in the Boolean column. You may be able to guess where this is going. If I have it saved as text, and I say, give me everything where it's true, I've literally lost 4 of my responses. So if I'm trying to use Boolean in a text column, I either have to enforce a constraint on what can be in the column, or I have to enforce what I'm searching for at the other end. And we know how creative humans can be. We've got a maybe, we could have I don't know, we could have why are you asking this? Like a text column can accept a whole lot of things, right? So if you need to represent a Boolean, please use a Boolean. I know I feel like this is taking me a particularly lot of time, but I've seen it cause some true havoc. And I think it's really important to harp on. Null. Null has a special place in my heart. Null is used to mean several things. Sometimes null is used to mean I don't have this data. It exists, but I don't have it. Sometimes null is used to mean that this data does not exist. Sometimes it's used to mean this field is not applicable to this situation. For instance, in building codes, if you have a lot and it asks how many stories does this building have, but there's no building on the lot, you could say 0 stories or you could say NA. Which of those indicates that there's no building on the lot? Well, if you're forced to input a number and you're not allowed to give a null, then it's 0. But what if you've built a structure that's underground? Is that really a story? In some jurisdictions, no. As I said, a very special place in my heart. It's very common for software engineers to decide that we must have this information. It's very, very common for software engineers to be told, we must have this information. Get us this information. Force the person doing the data entry to give us something. People get really creative. And what happens is that your beautiful beach of your database gets a lot of trash dumped on it. So not just things like a building that doesn't exist being 0 stories, but for instance, in New York City, it used to be really common and understood for a building, number of stories in a building of 99 or 100 to be a very obvious marker that this was, we don't know. Now, we do have buildings that are approaching or over 100 stories tall in the world, so it's no longer a clear indicator of any usable information. So our accuracy is really taking a hit when we can't determine is that in range or not. It used to be very clear that this was not in range. Now we don't know. Middle name, middle initial. If you're forcing someone, there's all sorts of name stuff, right? If someone has only one name, and your engineering system has forced them to put in a first and a last name or a middle name, you get creative. You're in the emergency room, you're admitting patients, you have someone who has no identification. How do you say, we don't know? Well, we've had to design systems that say, literally unknown. Well, that's great. You are a traffic cop, and you're writing tickets for parking, and you have to write something in the license plate field. And because null means to many people this information does not exist, if a car literally has no license plate on it, null is often what is written, but then it goes into the system in a text field as the string null rather than the computer idea of null. And then Mr. Joseph Tartaro in California decides it would be really cool for him and his wife to get license plates null and void. He got about 20,000, not very precise here, got about $20,000 worth of parking tickets nearly immediately. This happened in 2019. As far as I know, it has not been fully resolved. That is everything. Oh, go me. Thank you all so much. This has been a delight. I'm looking forward to answering your questions and hearing your horror stories about similar problems with accuracy and maybe precision problems too if you've had them in your databases.
I'll be walking around with the mic for anybody who has any questions.
And if you could just wait for Corey to get to you with the microphone.
Hey, so maybe it was during the worst practices yesterday, but why should we use numeric and not double precision?
So double precision stores your data in a way that rounds it inside the database. So it's got a lot of precision, but it loses a little bit of accuracy in the storage. So when you multiply two inaccurate numbers against each other, you lose some accuracy. And if you've got 1 billion of those transactions, you lose a lot of accuracy. And it doesn't sound like a big deal to be doing that to 1,000th of a penny, but if you lose 1,000th of a penny 1 billion times, you've lost several $1 million.
And then why do we have the money type? And when should we use it?
I don't know,
If
and
at
I
all.
don't know.
Okay.
Yeah, Peter Gagan, no, not Gagan.
Eisentraut.
Yeah, Peter Eisentraut is, he sits on the SQL committee. He doesn't have a voice on it. He would be a good person to ask. Vic Fearing just joined the SQL committee. He would be a great person to ask why. Please don't tell them I sent you. I really don't know why we have it. I think it's just cruft, maybe. Corey, do you have any?
It was designed at a time when the notion of the number of decimal places money could go to was fixed and would never, ever change.
Always a good idea.
Yeah, they just really didn't look outside their front door when they built that one.
Thank you.
Any other questions?
Yeah, we've got one more. Corey's coming with the microphone.
I'm really not sure who to address this to, but I'm coming from an Oracle background, going into Postgres.
I'm sorry, and welcome.
Well, and in Oracle, for a text field, it's varchar2, and it has, we almost always will constrain the length of that field because we don't want to have people typing in crazy stuff. But for Postgres, I don't have a lot of experience in it yet. I'm finding that people are suggesting that we use text fields, and if we want to constrain them, that we put a table constraint on the field, which seems a little silly to me because you have character varying, which doesn't really flow as well. But if you're looking at metadata for that database, it's very obvious if you have a field that's character varying 100 versus a text field, then you have to sort of look somewhere else to find out the length of it. So why is that sort of why people are pushing rather than doing it a more obvious way?
For a lot of reasons. One of them is that, like Corey said, with the expectations about the number of decimal places that money could go to, when you design your database, it's very tempting to think, no one will ever have a last name longer than 15 characters. And then you go out into the broader world and you meet people from the Republic of Georgia or India or anywhere else in the world, and you learn, oh, it's actually a thing to have a last name with 30 characters. So if you've constrained in the database at the most granular level, you've broken your system for a whole lot of people.
But don't you then have more ability to preserve the accuracy of your data in some ways? In other words, the number of cases where you're going to have somebody with a longer than 100 character name is probably less than somebody putting the wrong field in there and you wind up with like
A Treaty of Westphalia.
Right. And so you seemed to imply earlier that constraining the data is bad because it leads for people to put in creative solutions to things. But on the other hand, if you don't constrain your data, you wind up with incomplete or missing data. So where's the trade-off there?
I think I would say that you are constantly and always and forever making trade-offs in data quality. You cannot have everything be perfect. You cannot have the most up-to-date data and the most complete data and the most accurate data. So you have to decide, what are we going to prioritize? And so in some cases, you may legitimately say, we are going to cause problems for the people whose last names are longer than 30 or 50 characters, because we see that with less frequency than we see with people adding lorem ipsum to our database in a way that gives us inaccurate and unusable data. How to make these decisions and trade-offs is something that needs to be done at a business purpose level, because it's different for every situation. And it looks like Corey's got someone else with the microphone.
My question also kind of relates to the constraints thing. So you talked about how you definitely want to use Boolean if it's really Boolean, but like there's a lot of cases where you might have some input that really is like yes or no, or maybe it's like two options, but you do kind of want the text. So I guess there's like three options, and I kind of want to know what you thought was the best, right? You could use Boolean and handle it in the code, or you can do text constraints, I guess, and then you can make a type. So which of those would you?
I wish I were a billionaire, because I would offer a prize for data where someone has collected more than 10,000 responses on a yes/no thing, and literally no one had come back to them and said, I need a maybe or an I don't know. So yes, no, I don't know. I would say sanitize it by giving people a drop-down box where they can literally only choose those things. But if you need to analyze data, you have to make your data analyzable. And if you allow people a free-form text box, they'll get real creative, including swear words. People really hate filling out forms. And so I would say for the data that you need, yes, no, maybe, and then explain more. Give people a text box to explain why they don't know or why they don't feel like this is relevant to them. Most people are good actors and want to help you have the best information you can have. Help them help you. And did you have a follow-up? No. Okay, thank you. All right, who's next? This is the most fun part about giving a talk. I was really hoping for some like horror stories or commiseration or further. Oh yes, got one. Maybe.
Yeah, I always don't like people who say I have more of a comment than a question, which is why I held off on saying this initially. I have lots of these horror stories. In my current role, I worked with lots of voter registration data.
Thank you.
And so like apartment complexes that have thousands and thousands of units in them, you'd be surprised how many people with relatively uncommon names have the same address. People who are junior and senior who live in the same house. Like there's such a long tail of crazy stuff like that.
I do a lot of door knocking. Van is amazing. Van is a voter registration database.
I did also have an actual question.
Yes, please.
So for the slide that you showed that was like a funnel of data transformation and cleaning, it sounds like you worked with Postgres a lot. Are there other tools that you like to work with for that process? Like, are you doing lots of transformations in the database? Are there like orchestration tools that you use to govern those transformations?
I myself don't do a lot of that. There are lots of tools, and like we were talking with earlier about constraints and how to choose a tool, it's really going to be trade-offs. The good ones cost money in a lot of cases, and because I don't work for any of them, I'm not going to dip my toe into the water of like making recommendations on a recorded platform. But also genuinely, I don't have enough experience transforming data to make a recommendation of one tool over another. But if you can try more than one, try them, see what you like.
I could also just share another absolute horror story.
Great.
And this one relates to the duplicates without duplicate IDs.
What's with duplicate IDs?
It's like duplicate items, but without duplicate IDs. So there's unique IDs. Like we deal with a lot of GIS data, and we deal with like municipalities, and a lot of them make their own data or edit their own data. And I've seen things where it has a distinct ID, but it just is the same. It really relates to the same thing in space. So it's in the same location. It has the same attributes, but it has unique IDs where even sometimes where like each attribute is its own row in the table, which is like absolutely horrible. But yeah, so JS definitely has some like horrible data as well.
Very, very common. Someone will come along and document an item, and then someone else comes after them and documents the same item, and neither of them knows that the other has been there. So now you have two records, but then it's the question of like, oh, is it possible that they are two distinct things and someone had a calibration problem on the, tool that they were using to determine their location? So are these things truly in the same location, or is one in a different spot?
Yeah, it's an absolute mess too because
Microphone.
it's an absolute mess because then if you want to use the data, you need to figure out how to merge those together, and it's not necessarily clean, and you may have attributes that are duplicated, so like it may be slightly different with certain attributes, and how do you merge, how do you choose which one to keep and which one to throw out? So.
This is a problem with people, with addresses, with real estate, with chemistry. Animals, there are like the same animal has different names, so if you put it in the database, it looks like two animals, but it's the same animal. Yeah. I'm hoping there's one more question. We have a few more minutes, but it is also snack time.
I can offer one of my own.
Amazing.
Okay, it is not a question, but I was once tasked with explaining why a particular search in a database on the word curacao was not coming back. And I could find the record they wanted in the database, but I could not understand why my search function was not pulling it up. It was only after several hours of research that I discovered that there are in fact two distinct UTF-8 characters that have that C with a little sigil beneath it. And you need to go to at least a 32-point font before you can see the difference between the two. But that was the reason why, and many, many bad words were said that day.
Yeah, your character set is a whole other consideration. For instance, a lot of databases only take input as a Latin alphabet, so good luck recording your legal name if your legal name is not in a language where the alphabet is the Latin alphabet. And then we could have a whole other talk about transliteration of names into English or other names or other languages. It is a rich territory, and the territory is not the map. Okay, I think, I've got another one. Great.
One last one.
I'm happy to go into snack time. I'll take any questions.
Okay, I think I have, horror stories putting it a bit strongly, but one of those, and also a question, horror story. First, to anonymize it a little, imagine maybe you have a table, or something I've seen in prod maybe somewhere before. Let's say you have a table and automated systems usually update it, but there's a guide in some wiki somewhere instructing like people who are admins who need to modify something at some time. And there's this one very particular timestamp that they say to use if you have to do this. Let's say it's like the epoch time, like 1337 or something like that, and
something distinct.
Yeah, something distinct like that. And apparently this is just there's no column saying like admin action taken or anything like that. So instead, this method was creatively invented to do that without doing like a migration.
A compromise.
Yeah. Anyways, question: Do you ever think of accuracy in terms of, or think of trying to like quantify accuracy in terms of like SLAs or like give it a number of nines of like what the data set is and have something like an SLA in terms of what one tries to guarantee with the database?
I try not to. Because it's such a multifactorial problem, and every schema is different, and every table is different. And every source is different. Some sources are going to be relatively reliable, and other sources some municipal sources may be more likely to have problems. So, data provenance, where did it come from, where did it go, what happened to it in between is going to have an impact on how the quality is going to go. And I'm not producing data, I'm analyzing data. So I don't get to hold anyone to any sort of accountability. So I just go into the data and I do things like check the range, check the completeness, look for null, look for weirdness, check the standard deviation, see like how weird is this. But there isn't really anyone I can go back to and say, make this data better. So that's why I'm here speaking at conferences saying, please, when you design your database, think of me. That was good. I wish I could, quantify how accurate is this. And this is something that when I do analysis and reports, I do say, like, keep in mind that this analysis is based on a data set that's only about 75% complete. So while this may be directionally appropriate, it may not be very accurate. Yeah. Okay, with that, I think we can wrap it up. Thank you all so much.